Hello class, in this tutorial I'm going to show you what you need to do for problem 7.18, which is having to do with sampling without replacement and with replacement. Basically calculating the mean of all possible sample means and the population mean and making that comparison whether or not the sample is biased or unbiased. In part A and B, you basically had to develop the data set, the sample for whether or not there's pairs of 2s or samples of 3. And you're just given a little data set for what contains 6 numbers, and it's these numbers right here, 1, 3, 6, 7, 9, and 10. That's your data. Subsequently, it's your population data. So I do want to just say that I'm not a big fan of this concept or even having to do this work, simply because in the real research world you're not concerned about things like replacement or without replacement. Whether you're taking a sample of individuals, a sample off a production line, the concept of with and without replacement, it's moot. Because you're always just going to be taking a sample anyway. So it is what it is. Really what the driving force should be is knowing that your sample is representative of your population. So that's the take-home point. But for this particular problem, I'll show you just the math involved, and it's easy, but it's manual, and you just got to repeat these steps a couple times. So for part A, with a sample of 2, there's a couple of different ways to set up your data. I show both of them here. So I just listed the data here on the left side, and basically every combination thereof, because there's only pairs of 2s. So we got, and you have to calculate the average for each of these. So what you'll see here is what I did is I did the summations vertically and calculated the average for each of them all in one shot. And so what I did here, so you see 1 plus 3 divided by 2 equals 2. The way I have this set up is that each of these formulas I pressed F4 to lock in the absolute value for each of these, and then just repeated that for this set, repeated it for this set, and this set. So what you'll see here is I typed in the formula, just this cell plus this cell, put the absolute value on here, and just divided it by 2. Easy enough, right? So if I just show you each of these, the formula, the value that's locked in is A3. So this is 1 plus 3 divided by 2. This is 1 plus 6 divided by 2. 1 plus 7 divided by 2. So on and so forth. The next array is 3 plus 6 divided by 2. 3 plus 7 divided by 2. So hopefully you see the pattern there. Then what you'll see here, you need to calculate the average of these, and you can do that in a couple different ways. Just by highlighting it, you can get your average down on the bottom here. But to do it manually, we have our sum. So the sum of these is 90. We have a denominator of 15, means there's 15 of these, which gives us the mean of all possible samples is 6. Or you can just do the formula like I did up here. The average for this column is 6. Now, the population mean is simply the mean of this, the average of these numbers. So you can just put in sum in those values divided by 6, or put in the average function to get that. So that's A. And what you'll see here, comparing 6 to 6, they're exactly the same, so this is unbiased. For the n of 3, I'd set up the data a little different way so you can see the combinations. So every possible combination is listed here. So 1 plus 3 plus 6, 1 plus 3 plus 7, and then just did the average right across. So this average function here is just typing that in once and then bringing it down so you get all the values. And again, just to show the math, here's the sum of these. The denominator is 20 samples, gives us a mean of all possible samples of 6. Again, you can bypass this step and just use the average. And our population mean again is the same, so again we have an unbiased comparison here of our sample and population. Now it's a little different for D, because part D of the question is asking with replacement. So if you can, this is why I did this, you can see the difference here. Basically we get to replace our 1 and 3s and 6s and 7s and 9s throughout to get all the possible 2-number combinations for the sample. And then this is just simply the average for each of these combinations. So the math is the same. We got a sum of 216, which is also can be done factorially. 6 to the 3rd gives you 216 as well. There's 36 records here, and you can see that count down below, which gives us a mean of all possible samples of 6 again, or population sample of 6. So again, this is an unbiased sample. That's it.